Okay, so this is paper 2, February, March 2021, and the variant 2.2. So look at the question number 1. The question is, answer all questions in the space provided, complete table 1.1 by stating whether each of the quantity is a vector or scalar. Very simple. So acceleration is a vector. Power is a scalar. And work is also scalar. So 2-mark question. Next question is the variation with time t of the velocity v of the object is shown in the figure. So this is velocity. So positive velocity because all values are above 0, no negative value. So the velocity in one direction, yes, it is increasing, then constant decreasing, but in one direction. The question is determine the acceleration of the object from t0 to t4. Look, from 0 time to this 4, the line is straight, so we have to calculate the gradient of this line. So the gradient y is equal to mx plus c. So we will write acceleration is equal to change in the velocity divided by time. So for the final velocity, this value is 1.4 minus the initial velocity. And this initial velocity, this one is 0.70 divided by the time taken for this is 4. So 1.4 minus 0.7 divided by 4, the answer will be 0.175, or we can write 0.18 meter per second square. Now the next part is determine the distance moved by the object from t0 to t4 second. Now from 0 to 4, we have to calculate the area under this graph, this one. So this is trapezium. So the area is the distance, mean 1 by 2, sum of the parallel side multiplied by height. So 1 by 2, one side is 0.7, other side is 1.4, and the height between these two is 4. So this is 2.1 multiplied by 2. So the answer is 4.2. So here we have to write after the calculation the answer 4.2 meter. Now the next part is define force. Simple. Rate of change of momentum is called force. This is the answer. Now, the motion represented in the figure 1.1 is caused by the resultant force acting on the object. Resultant force mean which is producing the acceleration. On the figure 1.1, sketch the variation of the F with time t from t0 to t12. Numerical values of F not required. Look at the graph. From 0 to 4, this acceleration is constant. Then 4 to 8, this acceleration is 0. And then from 8 to 12, this acceleration is negative. This is positive. Now, this line is steep as compared to this one. So the negative gradient is larger than this positive gradient. So we will draw here the graph. So in the first 4 seconds, the acceleration constant, so the resultant force constant. And for 4 to 8 seconds, it is 0. And then from 8 to 12, it is negative, but greater than the previous, the positive acceleration. So positive force is small, and this negative force is large. So this is the graph. So vertical X is a force and numerical value of the F not required. So this is the question number 1, marks total 10. Now move to the next question. Question is, state what is meant by the work. So we will write here, product of force and distance covered by the object in the direction of force, in the direction of applied force, is called work. The next, the beach ball is released from the balcony at the top of the tall building. The ball falls vertically from the rest and reaches a constant terminal velocity. The gravitational potential energy of the ball decreases by 60 joule. As it falls from the balcony to the ground, the ball hits the ground with a speed of 16 meters per second and the kinetic energy is 23. Show that the mass of the ball is 0.18. Look, the kinetic energy is given, speed is given, so mass is required. So kinetic energy is equal to 1 by 2 mv square. Kinetic energy is 23, 1 by 2 m required, and speed 16 square. So 23 times 2 divided by 16 divided by 16. And this is the mass. After the calculation, the mass is approximately 0.18 kg, hence proved. Next, calculate the height of the balcony after the ground. Look, the potential energy is given. This gravitational potential energy is 60. So we will use the formula. Gravitational potential energy is equal to mgh. So gravitational potential energy is 60. Mass is calculated 0.18. G is 9.81 and the height is required. So 60 divided by 0.18 and divided by 9.818. So after the calculation, 60 divided by the answer is coming approximately 34 meter. Next, determine the average resistive force acting on the ball as it falls from the balcony. Look, the potential energy, gravitational energy in the balcony is 60 joule. On reaching the ground, 23 joule is the kinetic energy. It means the rest of the energy is lost. So 60 minus 23, this energy is lost. And this is lost against the resistive forces. So the work done against the resistive forces, which is equal to FD. So the work done is this 60 minus 23, the loss of energy. F force is required, and the distance covered is the height of the balcony. So 34, 60 minus 23 divided by 34. And the answer is approximately 1.09, or we can write 1.1 Newton. Now the next is state and explain the variation, if any, in the magnitude of the acceleration of the ball in B during the time when the ball is moving downward before it reaches the constant terminal velocity. So we will write, when ball falls due to acceleration, its speed, or we can write velocity, increases. Due to increase in the velocity, air resistance also increases. Weight of ball remains same. Hence, resultant force on the ball decreases. Thus, acceleration decreases, and finally it becomes 0 due to the terminal velocity. So this answer. Now the next question is, a spring is extended by the force. The variation with extension x of the force is shown in the figure. This is a graph, force and extension graph. State the name of the law that relates the force and extension of the spring shown in the figure. So definitely this is the Hooke's law. Now, question is determine the spring constant. So we have to calculate the gradient of the graph or use the formula F is equal to Kx or Ke. And K is equal to F divided by X. F is equal to, from the graph, the maximum is this, which is 7 here. So 7 divided by an extension is 5 centimeter, 0.05. So 7 divided by 0.05, the answer will be 140. Next question is the strain energy elastic potential in the spring for the extension of the 4 centimeter. So energy is equal to 1 by 2 Fe or 1 by 2 Ke square. So 1 by 2. So what is the force for the 4 centimeter extension? This one. And this is approximately here, yes, 5.6. So 1 by 2 times 5.6 multiplied by extension 4 centimeter. So 4 divided by 100. And after calculation, the answer is approximately 0.11 joule. Now the next part is, one end of the spring is attached to the fixed point. A cylinder that is submerged in a liquid is now suspended from the other end of the spring. So extension is 4 centimeter. The area given, weight given, and the height of the cylinder given. Question is, show that the upthrust acting on the cylinder is 0.6. So we'll use the upthrust formula. Look, the upthrust formula here, the weight is acting down and the upthrust is acting up. So the difference of these two forces, this is weight down, the upthrust is up. So that is the tension this, or you can write tension up plus upthrust up, both are equal to the weight. Means sum of upward forces is equal to sum of downward forces. The downward force is weight and the upward forces are tension, the spring, plus the upthrust. Now the upthrust required, so W weight minus tension is equal to upthrust. So the weight is given here, 6.20. And this tension for the 4 centimeter extension from the graph we have done, this one is 5.6. So we will write here minus 5.6. So the upthrust will be 0.6, the difference of these two. Now calculate the difference in the pressure between the bottom face and the top face. So look, the upthrust formula is equal to pressure difference multiplied by area. So the definition of the upthrust is force exerted on the object due to the pressure difference between top and bottom. So the pressure difference is equal to upthrust divided by area. Upthrust is 0.60 and the area is given here 1.2 into 10 power minus 3. So 1.2 in 10 power minus 3 is 0.6. So after calculation, it is coming 500 Pascal. Now next, calculate the density of the liquid. So from the pressure, we can calculate the density. Look, the pressure is equal to rho GH. The pressure, or we can write density is equal to pressure divided by GH. Pressure is 500. G is 9.81, and the height, mean top and bottom, the height of the cylinder is given 5.8 centimeter, mean 5.8 into 10 power minus 2. So after calculation, 500 divided by 9.81, yes. So it is coming approximately 880 kilogram per meter cube. The liquid in C is replaced by another liquid of the greater density. State the effect, if any, of this change on the upthrust acting on the cylinder. Look, the upthrust formula is equal to rho G into volume. When the density increases, upthrust also increases. The extension in the spring, look, when this upward force increases, this one increases, this remains constant. So the tension decreases, the spring extension decreases. Now the question number 4. The question is, state the principle of superposition. So we will write, when two or more waves meet at a point, displacement of the resultant wave is the algebraic sum of displacements of individual waves. This is the principle of superposition. Now, the next is a transmitter produces microwave that travel in air towards a metal plate as shown in the figure. This is the transmitter, this is the reflector metal plate, and this is the receiver. The microwave have the wavelength of 0.04 meter, mean 40 centimeter. A stationary wave is formed between the transmitter and the plate. Explain the function of the metal reflector. So sorry, metal plate. So metal plate is used as reflector for the microwaves. Next, to calculate the frequency in gigahertz. So formula is V is equal to F lambda. Lambda is equal to V divided by F. Microwaves are electromagnetic waves that travel with the speed of light. So 3 into 10 power 8 divided by frequency is required. So here we will write the frequency, and here we will write the wavelength, and the wavelength is given 0.04, and the frequency will be 7.5 into 10 power 9. So this 10 power 9 is giga already written here. So we will write just there 7.5 because the giga is already written there. Now the next. A microwave receiver is initially placed as the position X, where it detects intensity minimum. A minimum intensity means the nodes, because the incident and the reflected waves are producing the stationary waves. So the node is formed at X. The receiver is then slowly moved away from X directly towards the plate, mean towards the reflector. Determine the shortest distance from X of the receiver when it detects another intensity minimum. The shortest distance mean the distance between two nodes is required. Now the distance between two nodes is equal to lambda by 2. And the lambda was given 0.04 divided by 2. So it is 0.020 meter. This is the distance, half of the wavelength. Now the next is determine the number of the intensity maxima, and the maxima mean the antinode that are detected by the receiver as it moves from X to the position that is 9.1 centimeter away from X. Look, this is 2 centimeter. And here the 9.1 centimeter mean one loop has a length of 2 centimeter. So how many 2 centimeter will be in 9.1? Look, this is the first loop. This is second loop, third, fourth. 2 centimeter, 2, 2, 2. So 2 plus 2, 4, plus 6 plus 8. And then 1.1 remaining. 9.1 minus 8. So 1.1 mean half, more than half of the loop. So this is lambda by 2, 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 but here will be antinode lambda by 4. So first antinode at this middle, second, third, fourth, and the fifth. So the total 5 maxima antinode will appear in the length of 9.1 centimeter, because one complete, second complete, third, fourth, and the fifth is half, more than half, because it's a 1.1. So this antinode will also appear. So the total 5 antinodes maximum will appear here. So the answer will be 5. Now the next is a source of the sound is attached to the rope and then swung at the constant speed in the horizontal circle. The source moved with the speed of 12 and emitted sound of the frequency 95. The speed of the sound is then in the air is 330. An observer standing a very long distance away from the source hears a sound. Calculate the minimum frequency to 3 significant figure of the sound heard by the observer. Minimum sound observed by the observer. So Doppler's effect, observed frequency is V times F divided by V plus Vs. So this V is given 330, multiplied by the frequency of the sound is 951, divided by 330 plus source speed is 12. So after calculation, the answer is coming 918. And the next, the circular path of the source has a radius of 2.4. Determine the shortest time interval between the observer hearing the sound of the minimum and hearing the sound of the maximum. Look, the source is moving in this direction. So here, at this point, the source is moving in this direction, mean going away. And here, the source is moving in this direction towards. So this is for towards, and this is for away. So by changing the position from towards to away, half of the circumference distance is covered. So the circumference 1 by 2 is pi into diameter, and the diameter is given 2.4. So the distance covered from towards position to the away position is pi multiplied by 2.4 divided by 2. So it's 1.2 pi. Now the time is required. So distance is equal to speed multiplied by time. So it is 1.2 pi. Speed of the source to move from this point to this point is given 12, and the time is required. Answer is coming 0.31. Sorry, its answer is 0.314. So we can write 31. Now move to next question. The question is, state Kirchoff first law. So sum of the currents or sum of the electric currents, sum of currents entering the junction is equal to sum of currents leaving the junction. This is the Kirchhoff first law. Now the next is, a battery of the electromotive force and the internal resistance R is connected to the filament lamp and the resistance as shown. The current in the battery is 3.6. The current is 3.6 and the current in the resistor is 2.1. This is the IV characteristic graph for the lamp. And the question is, determine the resistance of the lamp. So we have to calculate the resistance of the lamp. So resistance of the lamp R is equal to V divided by I. So look at this. 3.6 current is coming from the battery. 2.1 is going through this one. So how much current is 3.6 minus 2.1? It's 5.1. And what is the voltage for 1.1? It is 1.5 current, and this is approximately 4.4. So from the graph, so 4.4 divided by 1.5 after calculation, this is 2.93. So we will write 2.93. Next, determine the internal resistance of the battery. Now for the internal resistance, we will write the formula EMF minus voltage is equal to the last voltage IR. So the EMF is 12 and this voltage supplied outward, terminal potential is 4.4. The current from the battery is 3.6 and the internal resistance. So 12 minus 4.4 divided by 3.6. This is the internal resistance. And after calculation, it is coming 2.1. Now, the initial energy stored in the battery is 470. Assume that the EMF and the current in the battery don't change the time. So calculate the time taken for the energy stored in the battery. So formula, energy is equal to power multiplied by time. So how much energy is lost? 470 initially, 240 later. So what is the loss? 230 kilojoule. And the power is equal to I into V into T. So 230 multiplied by 100. Current from the battery is coming 3.6 with 12 volt. So 3.6 multiplied by 12 multiplied by T. So after calculation, now T is equal to 5.324 into 10 power 3. So approximately 5.3 into 10 power 3 seconds. Now the next is the filament. Wire of the lamp is connected in series with the adjacent copper connecting wire to the circuit. Some data for the filament and the adjacent copper wire is given. The average drift speed. Look, the formula is I is equal to eta QAV. So V is equal to I divided by eta QA. So both are connected in series. So current same, charge same, and this number density different, area different. So the drift velocity is inversely proportional to the product of eta and A. So we can write here the drift velocity of the filament is equal to the number density and area of the copper divided by number density into area of the filament, because inversely proportional. So after using the table, this is 2.5 eta into 360 A divided by eta into A. So after calculation, eta cancelled, A cancelled. So it is approximately 900:1. Now move to the next question. The question is, the result of the alpha particle scattering experiment provides evidence for the structure of the atom. Result 1, the vast majority of the alpha particle pass straight through the metal foil are deviated by small angle. A very small majority of the alpha particles scattered to the angle of 90°. State what may be inferred or deduced from this. Most part of the atom, first one. Most part of atom is empty space due to this one. And what is the result? Second, the central part of atom is dense, positively charged, which is called nucleus. So this is from the second one. Now, a radioactive decay sequence contains 4 nuclei, P, Q, R, and S. Nucleus S is an isotope of P. Isotope of P means this is 84 then. So it means here the alpha is emitted, here the beta, and again the beta. So determine the proton number and neutron number of the S. So this is 84. So after beta emission, this remains same. So this is 214. Next, the quark composite of the nucleus in Q is changed as from R. Changes as Q decays to form R. Describe this. Okay, so the question is the quark configuration of the nucleon in Q changes as Q decays to R. When Q changes to R, there is an emission of the beta from 82 proton to 83. One neutron is converted into the proton. So neutron combination in terms of the quark is up, down, down, and this is up, up, down. It means one down quark is converted into up. So here we have to write, due to the conversion of neutron into the proton, one down quark is converted into up. So this is the paper.